Hello everyone, welcome to my presentation. The title of my presentation is Preference Our Smart Hospital Selection System for Patients. I am Mohammad Sulaiman Choudhury, and in this research I have worked with Jennifer Rahman and Dr. Mohammad Mahfuzur Rahman. We are in an era where wireless communication is prominent to make everything more convenient for users. So, with the combination of mobile and cloud computing technology, we have worked on developing a system which can provide some important advantages to healthcare management. In our proposed system, the patients will easily get to know about their best matching hospital depending on their preferences. This work also integrates the techniques to understand the current situation of the patients and recommend them hospitals depending on their current situation. So this is the motivation part, and first of all, the idea came up from some developing countries where finding desired hospital is quite difficult. Hospitals do not provide equal quality of treatment, and as a result, patients have to face lots of difficulties while selecting desired services from the hospitals. In our system, user preferences are collected through a mobile application where in return the users get to know which hospital is best suited. Let me give you an example. Suppose I have been suffering from regular fever along with dizziness. I am expecting some nearby hospitals where I can get very good services with low prices. There is plethora of hospitals around me, and it is not possible to know which hospital has very clean environment with low price and good services. Sometimes I have to face an emergency situation, and this kind of situation makes me puzzled to find which hospital would be better and situated nearby. In this developed system, the patients need to provide some of their preferences or choices regarding hospital services. Each patient may also have various importance on each preference. Considering all this, the patients will be recommended about their desired hospital. As we know that researchers around the world are trying continuously to make our current hospital system more advanced and also to make it convenient for both physicians and patients. We have found so many works which are kind of related to our proposed system. Rashmi and Fadnavis proposed a model to find nearest hospital with the emergency ambulance services. Akash with his research team developed a system that reminds the patients about medicine time with some health sensing features. In another research, Tarannum and Monzu suggested to use some biomedical sensors to check patients' condition. Many researchers are currently using cloud-based service to make a smart solution for the hospitals. This cloud computing based architecture allows storing, retrieving, and updating patients' health records in real-time manner. Researchers also emphasized on the security and privacy issues as the patient's data is very much confidential. We also have found some researchers where they focused on security and privacy issues in the cloud-based health record management and used various encryption techniques to encrypt health records before sharing in public domains. So, in our system overview, our main focus is on selecting the best matching hospital for the patients based on their preferences and the importance on their preferences. The cloud computing infrastructure helps to provide real-time and automated management of the patient's information collected through various sensor or sources. A smartphone application will help patients to see their desired recommendation. Also, it will take the input regarding the patient's preferences, and in return, it will show the desired output to the patients that which hospital would be best for him based on his preferences. So, which hospital to select? So, one of the most common preference must be the hospital's location from the patient's current position. For this, we used Google Map and Google Places API to calculate the distance between patient's current position and the location of the hospital. From this distance information, the closest or distant hospitals can be easily identified. As far as we know, that Google Map has almost every major hospital, so in that case, we are not worried about missing any hospital. So many people from developing countries often worry about the quality services of the hospitals. It is quite difficult to know that which hospital has better service, as there are so many hospitals out there. To justify this situation, we use some information like user ratings, comments, etc. about the hospitals. We considered users' rating, comments of each considered hospital and use those information as one of our parameters, and that is hospital quality. Also, different people have different financial situation to spend money for the required medical services. Some people do not have any financial problem, no matter how much cost they have to pay to secure the quality medical services. On the other hand, some people have issues on spending money while they need to go to hospital. So it is one of the major facts in our preferences bucket. These are some examples of patient's preferences that we have experimented with, but in real life there will be more options in the preferences list. So here's an example scenario. First of all, a patient uses his smartphone to run the hospital selection application, and from that he or she will look a widget containing some preferences. From all the preferences, he or she has to choose his desired preferences and search for the hospital facility. This application would be very useful for all types of patients like regular health checkup, major health issues, or emergency health condition. There would be a real-time database in cloud infrastructure which will accumulate all the health information of a patient and recommend hospitals accordingly. This recommendation mainly considers the preferences of a patient regarding medical services. In our hospital selection system, we use two major functionalities. One is for best hospital selection, and the other one is for measuring the patient satisfaction. Based on these functionalities, we have developed our algorithm. So here's the two equations that we have used in our simulation. First one is called preference matching, and second one is called satisfaction rate. So in first one, this function helps to find out which hospital is the best for patients respecting their preferences, and in the second equation, this results the satisfaction rate of the patient, that is how much the selected hospital satisfies the patient's preferences. This is our proposed model, and the three major model is, first one is patient's preferences model, which is the users can provide their desired preferences, and the second one is called hospital's capability model, that how much a hospital can offer, and the third one is called hospital selection. This provides the best match between patient's preferences and the hospital capability. In this slide, we can see that there are three different matrices where the left two matrices are related to patients. Among the matrices in the left, the top one matrix V carries the patient's preference information, and the bottom one matrix S includes corresponding weights on the patient's preferences. Matrix V represents the preferences of the patients. We can take multiple number of preferences choices, and each row represents the preferences choices of each patient. Matrix S is the weights of the patient's preferences. It is basically to contain the weights on preference choices of the patients. For example, some patients may have higher importance to the cheap services, whereas some patients may have higher weights on the hospitals in close proximity. Finally, the matrix in the right side, matrix W, contains the hospital's capability information. The matrix W contains the hospital's capability information, and it is obvious that there are multiple hospitals, and each row represents the capability of each hospital. There can be different type of capabilities like cost, distance, quality, etc. For the evaluation, we created a number of real-life scenarios to consider varying number and types of patients' preferences along with their weights on the preferences, and also varying the hospital capabilities. For each scenario, we asked different users to manually select hospitals depending on their preferences and their weights on their preferences. Then we ran our application for the same scenario to suggest the patient's best hospital. We made a comparison to find out whether our algorithm produces similar results to the manual selection or not, and the good news is our algorithm results are almost the same as the manual selection. We can see that the comparison between user rank and application ranking. For the first user, most of the rankings are similar for the user and application. If we look into the second user ranking, we find that most of the rankings are also closer. Now, in the third user's result, the rankings similarity are not found as it was in the first two. We made some observation in this kind of situation and found a reason. The reason is it becomes more difficult to perform manual selection correctly when the patients are presented more number of hospitals with a closer capabilities. The result of the last user's manual ranking are found identical to the application ranking. So in the most cases we are getting expected results. So we have made an efficient system for the patients to improve the hospital selection process. We presented and referenced our hospital selection strategy, and with the experiment we found that our automated system performs very similar to the manual hospital selection. We hope that our preference-based hospital selection system can help the patient to find out a better hospital with the desired satisfaction. So thank you everyone, and thank you for giving me the chance to present our proposed model. These are the references mentioned in the related work slide in this presentation. These are the keywords related to our research work and this presentation.